start. Okay, yeah, recording started. So we earned the hour, so we can start our process. Again, I am Wrodek Maciej. I am a quality lead at Displate. Displate is company that is doing posters on metal, what it's called? Metal plates. They are very nice. They are not cheap, unfortunately, but I prefer them to normal posters, so there is lots of choose to there. So this is good stuff. And today we are continuing our adventure with unit tests and TDD. So our agenda, as you know, first days we're talking about basics. Yesterday we were talking about the mocking. We'll look about auto fixture. Today we will be doing TDD. And our agenda is very simple. We spend most of the day doing TDD. We will be doing it in the code. We will be sitting there most of the time. And I'm going to show you not only the good sides of TDD, but also bad side. Because what pains me is a lot of people are saying TDD is easy. Yeah, TDD is easy when you get into it, when you understand how to do it, and you have the ability trained in you. At start, it is very, very painful. I'm not gonna lie. For me, starting with TDD was difficult. It required from me much more brain power than writing tests after writing code, because I had to have the design in my head before I was doing the stuff. And after that, we'll do summary. We'll summarize what we learned on our all three days. And in the last 20 minutes, 30 minutes, depending how we finish, there will be time for your questions. Of course, if you won't have any questions, we'll finish earlier. It's not a recommendation for you to not have questions. It's better for you to ask questions, but just in case. And as always, we have breaks. We'll have 10 minutes breaks every 15 minutes. Last but not least, we are using still Visual Studio and GitHub for our code. And before we go into what is the subject for today, I wanted to show you our progress. Previously, on previous day, we have implemented a few more test cases. When we left, we have something like 50% coverage, and our last commit with added new functions to be covered have pushed us to 63%. So now we have much more coverage. We have even coverage of 100% on game results and game options and player actions. And this is why I wanted you to show code coverage, because it's not always fully trustworthy. We have covered 100% online on the class that basically is structure. Nothing happened here. There is no logic. There is no value in having code coverage here. And yet it grow our percentage higher. Why I'm saying it to you? So you would be avoiding the metrics that we have to have some percentage of coverage. There are so many ways to trick that, to get the fake result of that is impossible. But of course, it is always worthwhile to take a look what is going in the classes that are not covered and take it for yourself if you want to have it covered or not. I'm not going to cover as part of this training, but there are tags, attributes, comments that you can use in your code, making some lines not being counted for code coverage. It's also a solution. And yeah, so let's go back to our mirror for our last slide of all time. Oh yeah, first thing first, I'm going to send you again all the links to our to the stuff that we are using. Chat. Yeah, I was sending it not where I was intended to. So again, this is the link to the GitHub. This is the link to the Azure where the build is running, and this is the link to the Sonar Cloud. What I will do in a moment, and maybe I will do it right now, let's discuss a few books that you can use to learn. One of the best books, this is kind of the Bible for unit testing in C#, is the X unit test patterns. This is mostly collection of different patterns that we can use in writing unit testing. I will be using some of them, probably not even giving the attribution to this book. It's one of the best book, but it's expensive. It is, as you can see, hardcover is $68, Kindle edition is $50. In my opinion, that book is not that good. If you have in your company O'Reilly and you can get it through the O'Reilly, I suggest doing that, or I think it was previously called Safari Books, but just buying it for the book, I'm not sure if it's as worth it. I would suggest in your company, if you have developers, to have one copy, but that's all. The other book that is good and is little more in the accessible pricing range, it's the Unit Testing Principal Practices and Patterns by Vladimir Khorikov. I'm sorry if I butchered his name. This is the book I have used when I was learning, or rather relearning test automation some time ago. It has good explanation on many different aspects, and author has very good light pen when he's writing, so it's good read. My only surprise is there is audiobook version. I have no idea how that book would be working in audiobook. It's full of code. I cannot see it working in audiobook form, so I wouldn't recommend buying it with the Audible. But if some of you buys it, I'm really curious about the results, so let me know. And last but not least, there is book in progress on Limpap, TDD ebook. It's written by Grzegorz Gałęzowski. If you are interested in C#, it's a good guy to follow on Twitter because he has lots of great insights. He is great propagator of TDD, and this book is what he started to write to do it. What is important here, I have this book, I bought this book for the price, but he's doing it from his love for the community. So you can also get it for free, completely legal. Of course, if you are someone that has spare income, I would suggest you to buy it for some money to support the author. And this book has also great insights on TDD. I'm going to share the links to all 3 positions right now in Audible. In Audible, yeah, we are speaking on Audible in the chat. And last but not least, I'm not, well, Grzegorz is my friend, but I'm not associated with any of the author of these books in a way that I'm not getting any money from promoting this stuff. It is just the books I have in my recommendations for you. And so let's go back to our code, or rather TDD. So what is TDD? TDD, in very short, it's an approach where we are writing test first. But someone will tell you TDD that there is also test first approach, and it's not TDD. Yeah, I'm not going to go here in full details because we are still covering basics of TDD. TDD is basically a loop, red test, green test, refactor. So we are writing first test that has to fail, that is covering our expectation. Then we have to write the code until the test pass. Just until the test pass. Notice this, we are not writing more than expected. We are just writing bare minimum to make it pass. Then we are going to refactor. The standard loop is basically write test, test fails, run all tests to make sure that nothing is broken, write just enough code to pass, run all tests to see if nothing else is broken, refactor, run all tests, and go back to step 1. Yeah. In theory, it's just that simple. So let's see in the reality how simple it is. To give you full picture, so far I was writing the code that I was rehearsing. You've seen me getting issues coming from me forgetting something, don't remembering something, or trying to make something live differently. This time we are going it completely live. It's not rehearsed. I want you to show you how properly it is working on a real example that is connected to your learning. I have an idea what we'll be implementing. I have idea kind of how it has to be implemented, but I haven't written this code before. All code so far, it was at least partly written by me before it was writing here live. So it may end up differently. It may end up completely mess, but also it is worth learning. So what we'll be implementing for now, we have the rock, paper, scissors game, which has also wrong arrows, as I just realized. Let's remove this arrow. Why I cannot? What's going on? Why I cannot? Oh yeah, I was in the presentation mode. Let's remove this arrow and put it proper way. So this is our rock, paper, scissors dependencies. We have rock, we have scissors, we have papers. But our business decided that the game is getting stale and they want more variety of moves. So we'll be adding 2 new moves, Clippy and Sun. How it's working? Well, Clippy, basically we have make connection two things to things. So what's gonna happen? Clippy is of course better than a paper because it can clip the paper, but rock is of course defeating the Clippy. And scissors, well, scissors are not being better than Clippy. Well, because I'm clicking not the button I want. Because Clippy can make them dull, similarly to the way scissors is operating, which leads us to the Sun. Give me a second, someone is writing here. I'm going close to not see this, which leads us to the Sun having to be stronger than Clippy because we need to have few more things. We need to have balanced relations. So it's too much. Let's color relations that are going to out of Clippy. So relations going out of the Clippy will be red, that are connecting us to Clippy will be red as the new relations we are implementing. So what about Sun? Well, Sun, basically, if we could look at one thing, Sun should be able to defeat everything, but it's not like that. Paper is usually white, so it means it can defeat Sun because it will reflect it light. Rock can provide the shadow, so it will also defeat the Sun, which leads us to the Sun being able to melt with it heat the scissors. Don't ask me about this logic. This is business decision. They seeing some value in here. We are not business. We don't need to cover it. So here we have interesting situation. We have new dependencies on the element, and this is just the logic here. But let's look at our code, how far it will be stretching. So command line here, nothing will be happening, but user interface, oh boy. Here we are getting, and we have hard-coded information about what actions, how to collect the information, and what are the legal inputs. And then we have switch, which is translating one to the other. This will have to change, which already we are seeing. There is solid. I don't know if you are aware, there is solid principles. There are principles connected to the writing proper code and proper object-oriented code, which are going like single responsibility pattern, open cross, risk of principle, interface separation, dependency injection. This is something you can read on your own, but you need to understand two things. Basically, if the solid is broken, it's not properly done in the code, you will see it very easily on the fact you have problem with writing unit tests. One of the principles is open close. So the code should be open for extension and close to modification. And here we see the problem because this is not open for modification. It's for extension. It has to be modified. Of course, every code has some volatile points which are made this way. So this is kind of acceptable. We can live with it. So let's go further down. Move factory. Yeah, of course, that stuff will have to be edited. And as we can see, we have to extend our move types. So what next? Player actions. Here nothing happens. turns, nothing happens. Game engine. Game engine, yeah, it looks like it should handle everything well. So far so good. We have only one place that we need to change, two places that we need to change, 3. But look here. Each of elements have information with which it is winning, with each which is losing. It's kind of domain-driven design, so we are asking here elements for the information. This is kind of decision made on an early stage, because we could do two options. We could have one big switch or the option to extend values. In this case, we went with the object. So here we have some extension to do. And we have 2 new things to add. So let's start with adding new things. So basically what we need to do is let's run our tests. Let's run all our tests. We have everything green, so we are in the good place to start. And our first change that we have to do is we have to extend our move types. This is enum. There is no point writing tests for the enum, or rather the enum should be covered indirectly by others. So what we have? Flippy, sun. Let's run all our tests. Did it affect anything what we have covered in our tests? No, but you know what? There is one problem. We haven't covered everything in our tests, and we will see it in action in a few minutes. So first, we have done move type. Next, we need to create our new objects. We need to create first, it will be, let's start with the sun. Yeah, let's do it properly. Sun. Let's implement missing all the interfaces. Yeah, you should kind of, this is stuff for which we could do some you know, re-implementation, but let's for now just steal the code. Let's just steal the code. Later we'll look into the option to make it much more efficient, because we have here, yeah, we won't do it this way because we have class now, and I kind of started, you can see this is the temptation. We have class now, which means we can start writing the tests. I was already wanted to write the code before I wrote the test. So we have the paper tests. Let's do it properly. So let's create new class for the tests. Add new item. Some tests. Yeah, we have our. So we are making our constructor. Yeah. Yeah, tests. Let's add ourselves the sun test. So true equals sun. So this is kind of stuff that is semi-repeatable, so there is no shame in looking how we have only. Of course. I did it in wrong project. Yeah, I forgot to click implement. I clicked the wrong option here. Let's make sure the sun is available outside. So now it should be able to use the using, yeah. So let's take the paper test to have some inspiration. Yeah. So the very first test that we can do is checking if the yeah, let's add X unit also here. Void. So yeah, we have our move setup. So let's get our actual top type. Let's import missing dependencies. Yeah, not get type, but move type. So let's run our tests. Now it should fail. Yep. Our test has failed. So what is the bare minimum of code that we can write to make it easier, to make it working? Instead of throw new, we have here move type sun. Yes, passed. Now we're going into a more complicated case. We will be returning all the stuff here. So I'm going to do some copying here. Yeah, just to make it a little faster. For now, let's remove the inline data because we will need to check it. Sun is winning, return. Sun is winning, returns expected. We are not doing new paper, we are doing soot. And turn expected. Yeah. As you can notice, we now have a little more cases. We will have 5 cases. So let's open, I will open on the other screen to not to confuse you. So what should happen when the input is scissors? Sun beats scissors. So we should have the win here. Rock, paper, sun, Clippy. In case of sun, we have, of course, time. In case of paper, yeah, I have made the arrow wrong way on the paper. Paper beats sun, yeah. Paper beats sun. Rock beats loose. Rock beats sun also. Sun is time. Clippy is melted, so win. Yeah, we kind of done here a little more than expected because we implemented 5 tests at once, but this is, the test data, so it's not as big issue here. Yeah. Not implemented, not implemented, not implemented. So let's steal some code here. Oh yeah, I left the counter here that we have previously done. So yeah, I can also steal this. As you can see, we are doing code duplication. I'm already seeing place when we can do some refactor, and we will do refactor after we finish this test. So we are winning with scissors, and we are winning with Clippy. Hello, I think. Can someone tell me how much stuff we missed? Because it looks like I was disconnected for some time. Okay, I'm continuing. I'm waiting for some information from the organizers if there was some break, because it looks like I was disconnected for some moment. Yeah. Okay. So I'm not sure how much have you seen, at what point I was disconnected. I'm sorry for that. Basically, what we have done, we started writing tests for the sun test. And in writing them, we noticed that we have some code redundancy, some code repetition, which we'll be able to address now. Now we are writing the second case, second hour test, which is the one for the theory with different data. In theory, we have written here maybe 5-6 cases because each line is the one case we can cover. But let's not go into as much detail. Nobody in real world would be doing something as simply. So let's now check how it will behave right now. Okay, So we have went through with the scissors and clippy. Now we have the losing moves, which we are losing with paper and we are losing with knock. Okay, so let's run. Cool. Cool. But now the problem is starting on the other way. We have implemented the sun, and now is the question, what about the other tests? About the other elements? Because we have here also dependencies on the others, and we haven't covered them with the tests. What should we be doing now? Of course, before making changes, we should cover them with the tests. So let's start with the one that we already have some code coverage. We have the paper. So in case of paper, we are missing two more cases because, well, for now one, because we are adding sun. And as you know, sun loses to paper, so we have here win. Let's run again of our tests. Oh, there's counter. Where are we using this counter? Yeah, I forgot. Yeah, so as you can see, I also made another mistake I shouldn't be making. After making my test pass, I forgot to run all the tests as I should. There are still more two cases. Okay, so let's go back to our paper test. Our paper test failed because we have no implementation for it. So paper is winning with the sun. Okay, let's check now. Everything is okay. Okay, so now we go into more complicated territory. Rock. For rock, we have no test implementation. And here are two schools. Should we write the test that is only covering what we are changing, or should we write whole coverage? Personally, I am of the opinion you should do also bare minimum of the tests, unless this is the session when you are going to cover all stuff. So we're going only to cover our new implementation. Maybe later we will extend it. So let's create our new file here. Mm-hmm. So, yeah. Let's already do theory. And rock is winning with the sun. So let's run all our tests if still they are green. There are not, because we have made the new stuff. And in that case, let's add the move type sun to our stuff here. And let's run our tests again. We have all green. So. What's next? Next is adding it to the move factory. Move factory has some tests. So basically here isn't much work. Move sun. So our test is failed. So we can add the new case. Okay, so we have some stuff done here, but I was talking about the refactor. So when we had done the tests, we should be doing refactor. And we are seeing here in our rock, paper, scissors, some code that should be refactored. So why I am not refactoring it yet? Because we don't have a coverage on those other tests. I would have to write tests for each method that I will be changing. So in this case, refactoring this into something that is more reusable, I am treating as the separate task, which we'll be doing after we implement the next case. So sun is done in the factory. We have done it in the rock, but we haven't touched yet the scissors. So time to deal with the scissors. Let's do another file. And that, yeah, you shouldn't be doing right dust. Oh yeah, because it's not pepper, it's scissors. Let's say a few minutes. Scissors, glues to clippy, to the sun. So let's run our code. Yep. Great. We have the code. Now let's move it a level further. We have the sun practically done. Well, not practically done. We have it also to be do changes in UI, but we'll treat UI as separate story. So the other story is now, let's do some refactoring. No, right, first. Yeah, let's do refactoring. Because at this point, we are seeing the issue that we are facing, which is we have not enough test coverage to make the refactoring into our stuff. So we will going to get the full coverage on the stuff we are missing the coverage. And then we will be doing refactor. Some TP scissors. What will be next one? Scissors, papers, rock. So with sun we lose. Oh, and of course, with sun we lose, with clippy we lose, with scissors we tie. Yeah, we haven't yet implemented clippy. Clippy shouldn't be here, and I kinda spoiled a secret that is an issue on our agenda. And with rock we lose. What does it mean? Now, this test should be fast because it's done after the case. And similarly, we can copy our test from the sun, which is the get type. Yeah. Let's now do the same for the rock. So the rock will be also on the case. Okay, so now we have the test coverage and we can go with the refactor. Why? Because what we see here is we have a lot of common code. We have in the rock, paper, scissors. Let's put it all again in the same case. Basically, what we have here is only we are changing the setup of the list. And that's all. All of the code rest is exactly the same, as you can see. Probably some of you seen it before, but I will show you. Just look it again. This is the same. The rest is similar. So what we can do, we have interface move, which is responsible for doing this stuff. So now we can make another object on the way. We can move an abstract class. Let's, normally I would call it move, but since it's called move, it will be called abstract move, base move. So let's go to our code here, which is here. And we will create a new class. Yeah, it can be external because it will be internal abstract class. And in our turn, we can copy this code because it's actually being moved here. And Proc will be using this one. Yeah, so you also have to be public. So actually, we don't need this method anymore here. But what we need here is, let's make you to protected because we will need you to be accessed by your child. Ah, yeah, right. In this case, we are using where I deleted here abstract. Let's see if everything works right now. Yeah. So what we did, we simplified our app implementation quite a lot, and this now works. So what we need to do is we need to do something similar for the other classes. Paper will now use abstract move. These implementations are no longer needed here. Interesting. Because I did it this one. So that was my issue here. So in this case, we'll have to do it. Yeah, we can do it this way. And we have to do the same in case of rock. Yep, everything is pressing. Paper is done. We are left with scissors, where we have to do exactly the same thing. And let's run our tests. Ta-da! And this is time for the break. We will see in 10 minutes when we will be running the sun, the Clippy. We will see a few problems with the Clippy, and then we will be moving to changing the UI. See you in 10 minutes. Okay, we are slowly back, and let's return to screen sharing. Screen share, second screen. So let's see if during the break, I have published our code, but it's still in the middle of running. So let's see in a few minutes how it's working. But now let's return to our cases. So what we have done so far, we have covered the code, I'm sorry, for the refactor, which will allow us in future to add new moves much easier. Originally, it was, done fast, done easily, so it was lots of copy pasting. Now we are looking into the future implementations. So what is next move? Next move is to add the code for the Clippy. And let's create new class here. And let's do some copy pasting because basically lots of the stuff will be very similar. Public. Let's not go this far. Public. So now we went even step further. As you can see, Clippy is being marked as red because we don't have even implementation of Clippy right now. And oh yeah, I forgot Clippy tests. And it is red. Of course, there are ways to generate the code, which will generate as the class Clippy, but it will generate it in the wrong project, so we won't be using it. Of course, this is also a form of TDD because, as you can see, we won't be even able to run tests, which means, yeah, tests are red. So let's go to our backend. Let's create our new item. VP. Public class Clippy. Abstract move. Our constructor is without type because we're sending move type. Twinkle. It is here, so let's go. That's why. So we kind of also, thanks to it, went one step further. which means we will have to add ourselves the test also for Clippy. Fact. Some test. Let's copy it. And next test, of course, is our test data. So let's look at our matrix. First, what are the relation of Clippy with different things? Rock is winning with Clippy. Win. Scissors are also winning with Clippy. No, sorry, scissors are losing to Clippy, so we won't have issues. There is lose here. And Clippy beats. Wait. If I'm looking wrong at this diagram, scissors. When we have scissors, Clippy wins. When we have paper, Clippy wins. When we have rock, Clippy loses. When we have sun, Clippy loses. When we have Clippy, tie. So let's run it all. Yep, we are failing. So let's go to our Clippy. And here again, we can do a little stealing. New list, I'm not certain. So Clippy with sun wins with scissors and paper. Let's run. Okay, next one we have the fix with which we lose, which is again the fragment of code we have to implement. Which we lose with rock and sun. Okay, so we have our new move implemented. Now we need to make it deal with other stuff. Other stuff it needs to be able to run. Let's run all our tests again. Everything is green. So far, so good, so easy. Let's go. What is next to change? The move factor. It doesn't have the implementation for now, which we will be addressing shortly. Let's go to our tests for move factor. In this case, it's not a lot to add. And let's run all the tests. Test failed. So yeah, let's go to the line via this one. And now we have the move factory covered. Move factory is covered. Now another thing starts. Now we need to cover all other aspects. We need to cover our scissors test, our rock test, our paper test, because we have added new relation. Okay. Let's start with the paper. So what happens when paper gets, yeah, let's copy this row. Clippy. Paper should lose to Clippy. Okay, so yes, lose, lose, win, win, tie. Looks everything great. Let's run the test. Yeah, paper is losing. We can go to our implementation. And basically, we can add. Yeah, it's brought me to the basic implementation. We can go to our paper. And we can add here move type Clippy. Let's run all our tests again. Oh yeah, I ran the debug by accident. Sorry. And we have all green. So we can close the paper test. Let's look there at now scissors. Again. Clippy, by the idea, Clippy should win with the scissors, because look at here, we have lose, lose, win, win. And here, scissors is winning. What will happen here? We have some issue. Scissors issue in business. Scissors, if the Clippy is winning with scissors, scissors should be losing. Somewhere on our graph in our business, we have issue. This issue was found on the level of the code. Of course, it couldn't be found before, but we have found it in our implementation. So let's look one again on our graph and let's see if nothing is broken here. So let's put the arrows that are meaning to win on that are meaning to beat on one end, and arrows that symbolize what is being beaten, let's come from the other end. So it looks like our, no, not you, not you, no. Oh yeah. So, as you can see, we have here an issue. The rock is actually our rock star. It beats a lot of things, and paper and the Clippy, not Clippy, the scissors is our weakest element. It beats only paper. So some relation has to be changed. And we cannot move our black relations because they are the one that are already in production. We shouldn't be touching them. And so what can happen here? What happens if we change a relation of the Clippy? If we change Clippy, it either can lose to paper, but then paper will be winning too much, or we can change it in relation to stone, but it will be lots of changing here. There are not simple stuff. If we would find it on the design, it would be much faster, but finding it here, it's also important place. So what can we do? The easiest way to fix would be to change the logic on the level of the Clippy. Or sun? No. Yeah, or on the sun. Because if we change it that sun bit stone, and sun loses to to a rock, we will be in much better situation. So what happens now? What happens when we find such thing in the code? In my opinion, right now, let's comment our test, because this feature would be implemented fully. We will need to do, oh yeah, we passed our test, but we'll be looking at it later. We will need to figure out how we deal with it. So let's see our new suggested change. Let's put it this way, but let's put it at, no, wait, the other way around. It should be go done. But let's give it green arrow. So now this way we would be covering everything. Everything should have to going out to going out. And now it's the business problem to figure out what is the justification for why scissors are winning with the sun. Let's say they are shiny and they are reflecting the sun. And why the stone is losing? Well, because it's the trees will be growing on it, or the grass will be growing on it thanks to sun. Yeah, solution found. So let's go back to all our tests, because this is example of case when the implementation is very problematic. And now is always in that situation is case, what should be changed first, the tests or the code? We have coupled very tightly our logic with the tests, making so the changes in logic requires changes in tests. It has its pluses, it has its minuses. Now we are able to see its minus. If we can find the tests, it would be the easiest, but in my opinion, in such thing, I think easiest way is to make the change in the code and seeing the effect. But again, we don't have a simple place to change. So let's start. Yeah, let's start this time prepared. Let's start with the test. So what happens here? Now sun is losing to scissors. Sun is winning with rock. Our sun test failed because we have made the changes. Let's go to our sun. And our sun also has the old implementation. So since we're doing changes here, we can already do full changes. No, I did it too much. Mhm. Wait, am I changing the right things? 1 second. Mm. So Sun win with paper? No, loses to paper. Yeah, loses to paper and loses to scissors. And it's winning with rock and clippy. Run on. Great. Now let's see all other our moves that we have affected. So Sun relation was changed with rock, and its relation was changed with scissors. So let's go to the scissors. And to the rock. Oh, and we kind of forget about our case here, which we'll be covering in a second. Yeah, clip in the middle implementation, so not to be here this time. Scissor is win. Paper is lose. Let's run on. Let's see if everything else is okay. And change to rock. Rock is losing with the sun. And we have averted our crisis. In the meantime, first, let's see if everything is building. Yeah, it's building because we test. Let's make the commit. Yeah, Sun has business back. Let's commit it, commit and push. And in the meantime, let's see how our code coverage looks our latest changes. So we have added 13% more code coverage and we have added 60 new lines. Let's look how it actually looking inside my branch. We are going to 76.9% of code coverage. Let's look how it looks in the code. Rock, paper, scissors is covered in 70%. Here we have in moves, even we have 94%. Game engine still doesn't have the proper coverage. Okay. So let's back now to our proper implementation of Clippy. So what was decided on Clippy? Clippy wins with scissors. Yeah, I'm sorry, I was in the wrong place. I should be going to scissors. Test passed. Next on the list, rock. Rock wins with the Clippy. Let's make sure if I remember correctly. Yeah, rock beats Clippy. Mm-hmm. And this is the point when we should all our stuff covered. Sun has 5 here. It has 5 here. It has 5 here. It has 5 here. So our simple case was covered. From the perspective of backend, we are kind of done. Well, not really, because from perspective of our code, we don't have covered the what is called the method, the game engine method that is actually doing all the logic, the run game. But from the perspective of the whole technology here, what is happening? We don't even care about it because we haven't touched anything here. All the logic is handled by our elements. Here, what is happening? Hell, I will show you even something more. Right now, our UI doesn't know yet about new implementation we don't. So let's play the game. We don't even have assigned the letters. And you can see we will have one problem because scissors is S, so sun will be problematic. So what can we do? Let's say, let's try something different. Yeah, it doesn't work. We can play rock, we can play scissors. Oh, and we have the breakpoint here. So let's finish the stuff. And paper, rock, rock, scissors, scissors, rock, 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 scissors. Yeah, one of the player won. Done. So, what next? Yeah, I'm removing unnecessary things. So what next? Now we will need to look at our user interface. Here we have little more information to handle. We have the legal actions to deal with, and we have the switch to deal with. So what we can do here? Let's look at our test first for user interface. Display doesn't care. We don't care about it. We care about player actions, and we care about the we care about the player actions. And basically, this is all what we care about. So here is the thing. As you have noticed, previously, we didn't do much of the caring about the messages that are being displayed. Now we will kinda need to care about them. So first thing first, let's say we will implement our new thing here. Let's add here the, what it will be first? Sun. Why? Sun is on S and it also scissors are on S. So what our business decided, the letter for them will be U because the second letter of the sun. And they originally wanted us to write SU for the first two letters, but we pushed back that there is much more expensive implementation of it. And yeah, this is here, which is not useful. And let's see now what's gonna happen. Oh yeah, those are still running. Yep. What happened here? We found one of interesting issues of our implementation, while true, which will go until the infinite ad infinitum, because we don't have limit on how many repetition we should do. So this is also something that we should be changing, and we will do it in the moment. But from our perspective, this means that this test kind of failed. So let's take a look at the situation. Testable user interface. And let's go to our user interface. So what we have to do? First, we have to do not many things. We have to add our new letter. And let's already update the message. Or let's do it this way. Yeah, this one seems better. Yeah, more devil. And let's add our case here. And let's add our tests. Oh, something failed. First, it failed because I forgot to change here to sun. That was on my issue. But the other issue was here we have scissors, not sun. We have standard issues of copy paste, not changing what should be changed. But there is one more test that is failing. Let's run all tests. The take user input, because we have updated the message, and this is the place where we're checking the message. So again, this is kinda wishy-washy if such detail of checking should be done in the test. Actually, this information should be going from resource file, and we should be putting it there. But for our simplicity, we have it here. And basically in the code, we would be checking if we are using right resource information. Yeah. The test has passed. What does it mean? It means when we play, we should be able to use the sun. So play, player one plays rock, player two plays sun, and sun beats rock. So player one plays scissors, players two plays sun. Of course, point for player one because scissors beat sun. Let's not discuss the logic. So he plays the paper. Oh yeah, I just checked on this paper, and he plays the sun. Yeah. etc., etc. Let's quit. Great. So now let's say, let's first update, we will update the message. So the clippy is added. Let's run. Right. What you have seen here is situation that I again clicked the run in debug mode. What does it mean? When we test assertions in debug, the code is made on debug if assertion is throw to put you on the assertion. And unit test for assertion are also putting us there. So let's not do it with assertion with the debug this time. Yeah, our test is failing because the new message is not there. So let's update the user interface for the new message. Let's run all the tests. And meantime, let's start preparing our next test. Yeah, we again are failing on this test because we haven't re-implemented the stuff yet. So our last case is so yeah, now we can play the game with Sun and with the Clippy. We can play Clippy against Sun. And yeah. Congratulations, we have finished implementing feature using TDD. Of course, let's be honest, that was very simple feature. That was a very simple feature in code that was already quite known to us. The code was kind of made with some thinking about extensibility, not with the great extensibility, but with some. We had to make some refactoring to make stuff as us. And of course, there is a lot of similar code in the tests which we can reuse. So at this point, you may ask yourself one question, Maciek, or you can ask me, Maciek, what about this all? Oh, yeah, I've done liter too much. Give me a second. I completely forgot that if you move a mouse a liter, it will be closing the screen. So what about this stuff? Those tests are looking very the same. Can I do some more generalization on the level of tests? Can I maybe do here some method that will be basing on the type generating test, that kind of stuff? You shouldn't. You can. There are some cases when it's good to do that. They are very rare, but basically you have to understand that even if the tests are the same class code as the production, there are few different rules. First, in C#, we are accepting the underscore names in the test. We are accepting much longer name in the test. And second thing is the repetition is much more allowed in the tests than in actual code. Here we can have some repetition. Here we can add much more things to make it much more readable. So no, you shouldn't go that way. It's better to do even a little copy paste. I know copy paste is dangerous, or maybe you can write some templates. Personally, if I would see that we will have more in future move times, I would be adding more relations. Maybe in future business will add more move types, and maybe he will go even further. You can select what moves are available in given game. That would be interesting. And yeah, so now the tests are running, and we will think about our next step. First, we have technical improvements to do. We have the user interface get the legal user running on while true, which leads us to the situation where if we don't get any input, it will be going in ad infinitum. It's not good. Business doesn't want that. Business wants to accept the fact that something may be screwed up. Maybe players have problem with the keyboard. I don't know. So they decided to put here a limitation. Only you shouldn't have more than 10 repetitions. So this will be one thing that we'll be implementing, limitation of 10 repetitions. And the other thing that they want to implement, you will notice its contradiction. They want us to implement a game not closing. So basically, when we will go, when we finish the game, it shouldn't put us on the menu, close the command line. It should be putting us again on the menu start to select play the game or quit. Simple. So, is it simple or it's not simple? It will be few things to look at. Okay, in meantime, let's see how our run is going in the on the pipeline. Clippy and Sun is in the middle of implementation in the running. Okay, we should have some results soon. Oh yeah, passed. At first thing I thought that I have I seen there skipped. So right now the code analysis is done. We look at the analysis. And after we look at or you know what, let's do break sooner. We'll do a break now. After the break, we will see how our code coverage is looking. And after that, we will finish our last implementation. See you in 10 minutes. Boom, boom, boom. So let's continue. As you can see, our latest commit didn't do much on the way of the code coverage. We fixed one issue, but we didn't change much. So business gave us two more stories to do. First, we need to implement the, first they said we have permission to do refactor as part of the story to implement the limited amount of retries. So this time, let's start with creating new branch here. So we won't be doing our operation on our master. So let's go to our tests. Let's look at our user interface tests. Do we have a test for legal user action? Yeah, but this one will be kind of different. Yeah, this one will be slightly different. User makes let's say game throws error. So yeah, business decide that we are assuming that if a player cannot do it 10 times in a row, there is error to be thrown. So again, we can write simple test here. This is not about printing. This is about throwing exception. So what we'll be doing? Yeah. We have our sequence for the mocks. But in this time, we don't need sequence. We will be returning all time one symbol. We'll be returning S. So we have the S. And now as it turned out, the expected print calls could be useful because then we'll know how many times you should be called this. Let's run. Oh yeah. Sorry, I forget about one thing. And fact that we'll be doing verification of this is one, but this actually is assertion error. Which one we will use here? We have here some, yeah, let's use invalid operation exception. Or we can create our new one, but for now, let's use just this. Or no, let's create our own exception. Our exception will be too many mistakes exception. And the method we'll be calling this is it's this one. And we need to add one more thing here. Yeah, this is kind of unnecessary. Now we need to create our exception to manage exceptions. Yeah, it will be one to create it here. Let's see what it created us. Yeah, it created in different place. Kinda. Okay, forget about this. Delete. So first I see Td Is exception. Yeah, already let's fix it also there. Mistakes. And it shouldn't be a problem. Extend exception. If my memory serves me right, I should do something more here, but it looks like they changed it for the net 6. Too many mistakes, exception. Okay. So let's see what happens now. Yeah, the test won't finish because our change is not implemented. So let's go to our user interface. While true. We can use for simply. Int e. No, we won't use local action. Mistake. Limit. Let's go. Mistake limit. The limit should be 10. And here we have information that not user code pass are returning code. So new. And let's run it. Yeah, now we have passed the code, which we can now commit to our branch. We have a new code. We have our too many exceptions. We have changed the loop. Handlet too many mistakes on input. Commit and push. Oh yeah, I forgot Testable files. So let's commit our changes. The branch is sent. And since we have trigger only on master, this won't run automatically. This one I will have to run manually. Run pipeline. Run limit retries. Limit retries, run. So as part of the story, we got permission from our bosses, or maybe we did it ourselves, to do some cleaning, to remove some different different issues we have. So let's start going from the bottom. So our first issue is in move get move move type move factory that we have the not very descriptive error. This one we won't be able to test because it's connected to enum that have limited number of values. And so let's just go to where is the move factor, and since this is just in case, nah, let's not be stupid. Oh yeah. Yeah. So this one is handled. What is next? This would be also handled by this. Another thing is this is kind of discutable. There are many schools. Some prefer interface to be starting with I. So let's follow it. I forgot to run tests first. As you can see, TDD is very easy to fail in the trap of your own confidence. Yeah, refactoring of the name shouldn't break anything. This one is very interesting one. First, it says to us that the abstract constructor shouldn't be public, which is very good suggestion. So let's go to our abstract move and make it. Let's see if everything is still running. But the other one may be more problematic. It wants us to set up the values for wins with, loses with, because we have here, we are not doing it. So let's do it here. And now let's see what happens. Everything passed. And let's do the same for loses with. Sure. What else do we have in the smells? We have addressed this. This is also a good suggestion. We are not doing any changes to the UI. So in game engine, we can change UI to read only. What else do we need? Read only is great. Yeah. Quit can be made static. Kinda doesn't change much for us, but yeah, let's make it static. Let's see if this will work still. But this one will be more problematic. Let's see. it passed. Last but not least, terminal can be also read only. And two interesting cases. Remember our test for an unit? There isn't much happening here, but it actually properly points out that what we just do to show up how to set up, it's actually not bringing any value from perspective of the test. And last issue to fix. What is the, oh yeah, expected result? We have in one test in our UI and parameter that is not used. Which one is it? So we've done some refactoring here. Let's commit our changes. And now let's move to the more complicated case. Now, yeah, this first thing first, we should be running this on our pipeline. Let's run new. And let's look first how we are here after our linter. First analysis failed. Why it failed? Quality gate, because we have introduced two new code smells. First, it wants us to add IC reliable to the too many mistakes. And second one is mistake limit can be made read only. I fully agree with the mistakes limit to be read only. It was in user interface. But the second one, I'm not so sure if I fully agree. First, it wants protected constructor to be added. Then it wants to make the system serializable attribute. So let's make it. Let's see if this will actually work. So. And now it should need constructor for it. Yeah, that will require a little more work. So for now, let's leave it out of scope. Let's just leave it at this level. We have here the issues. We accept them. What's going on here? Okay. Yeah, this one we can reset. We don't want this one. This one we have commit. Push. normally we should do it a little more cautiously, but since there wasn't many changes, let's merge it into current branch and let's push it. So our last task to do in our current form, create new branch. Okay, so far we were playing on this story is about addressing one thing. We need, let's close everything because we don't close all tabs. This story is about addressing our user interface. We have not exactly user interface. This is not actually on user interface part. This is on the engine part, as I just realized. We need to address our run game. We need to address one thing here. We need to address the information that after the game is finished, we need to start the new game again. So what can we do here? This one will be much more problematic because to write the unit test, because what's happening here? First, we have setup game, then we have game results, and then we have player moves. So we can kinda, as previously, change the setup game, and we will do it because we will set up this game as one game case. And after that, we will run the stuff. So let's write the test for it. So will we need our testable engine? Not really, but let's use it. So what we can do here? First, let's think. We will need player actions. We will need information from the interface. Yeah. So let's create first for ourselves the interface, because this is what we will be needing here. Yeah. So we have our mock, and our mock will have to return for us quite few information. First, we have to return the game options, which will be quite a shorter than usually, which means that UI mock, yeah, let's create here for options equals new game options. we want it to make it as short as possible. So UI setup, UI games option. So we have the UI mock setup, at least on this etap. Yeah, okay, for now, let's leave it here. The other option will be, what we'll have to return is game actions, which we can take any player move. So let's create our engine. And now we have our actual action. So should run game. What should happen? Basically, after we run UI mock, we should go back to our mock and it should be called again. Our method setup should be called again. So let's see if this works. So verify UI setup game. Is there option twice? No. So exactly 2 times. And in this way, we have our method ready. Let's see our test if everything works. Let's see if I wrote the test correctly. So let's take our game engine here. Yeah, I didn't make it correctly. So what we need to do, set up one more thing. We need to set up get player action. So get player action. It one second. What do you don't? Yeah, sometimes simple thing. So what would be returning here? Move type. So move type scissors, not just returns once. Returns move type block. And now I think about this. Here we also need return sequence. Okay, now I'm kind of stuck. I will be honest with you because I haven't thought about how to break the engine pen, the while loop here. I think the easiest way will be we will send in our test game results finished as true. But no, we cannot do it. We cannot do it this way because it won't be properly done. What we'll be doing, it will be calling back to setup game. And setup game is returning to us the game scenarios. Yeah, we could do it this way. So let's create one more game option. What I'm doing here is a little hack. Usually I would probably spend a little more time to look how I can do it differently, but to not waste your time, I will do it as this hack. So in reality, we'll do it this way. Let's see if now it will work or it will be still. Yeah. We didn't get the exception. So what now? Now we can start writing our code. Actually, the code is very simple. Well, true. So something went wrong. Or rather, let's see what went wrong. Let's put here a debug and let's run the test again. So it failed already on our first case. That is interesting. Let's see if I set up it correctly. I think the test is okay. The problem is in implementation. What happened here? A game is checking if the max options is greater than 1, and it should be taking if it's greater or equal 1, because we can have game to 1 win 2. So by accident, we also found another issue. So actually, it should be greater than 0. Let's run all again, and now it probably will be okay. So, oh, it's not. Let's go back. Let's see if I'm making another silly mistake here. Back. Step into. Okay, so you are returning. There is issue in the test. Let's look at it. Let's close it on. No, it's to be there. Let's see now what's gonna happen. So, for some reason that is unknown to me, game options is returning always the value of the setup sequence is returning game options and is only returning game options exit, which shouldn't. It should be returning first time this, then second time this, unless we are using is returning somewhere before the value, but it shouldn't be done because we see it's called only once in the code. Interesting case, which I think I didn't know about. So let's see if I have some fast idea for resolution. If not, we'll finish it here because I don't want to waste your time on me debugging code, such experimental code. Let's think. Setup sequence is using UI setup, which we have set up here. It doesn't have any parameters. it returns game options, and then it returns game options 2, which actually is the correct one that is being returned. So what happens if we change places them? I'm kind of curious. No. Yeah, let's do it temporarily different way, just so we will have some result to show. Let's see here. Setup game. UI continue. Continue kata. Control HT. Control HT. Never mind, it doesn't work this time. Let's run them all again. Oh yeah, this time we won't be throwing assertions, so And run now tests. Okay, now I'm starting to kind of mistake what I'm doing. Sorry for that. Let's remove that change I made here. Let's leave it as it was originally. Let's put it just 2, which means we will have to add Control PhD. And let's see what happens now. Yeah, now it passed. I may have made some mistake in my implementation of game engine. It looks like I have a mistake on this line, but honestly, I cannot tell you what is right now. I kind of got a little stressed that it wasn't running. This is not proper implementation. In real case, this test should be much more concise, but for now it's doing it case. So let's commit our changes. Let's run all the tests to see if everything is running properly. And yeah. Okay, let's see how our code coverage is looking right now. My branch has not really went better. I was expecting that after our changes, we will see less issues. Yeah, it kind of went better, but why it wasn't properly displaying it? Anyway, we need slowly to go to our end. If you have any question, this is the time to ask. I will be doing later summary. So at first day, we spent learning the basics. You've seen how to set up the basics of unit testing. We were playing with X unit, we were playing with N unit, we were playing with fluent assertions. And I'm still thinking that N unit is best if you want to do an integration or UI testing. And in case of anything else, I think X unit is winning for the TDD. It's better for the low level stuff. On the second day, we were playing with mocks. As you can see today, the mocks were vital. Without the mocks, we couldn't be doing lots of the stuff. And we did see in action also the the auto fixture. Today, we're doing TDD. I'm going to reiterate one more time the process for the TDD, which is first add test that will fail, run all test, write just enough code to pass the test, run all test. If it fails, go back, refactor, run all test. If it fails, go back. What you could see here today, because I was doing it especially without any preparation, you are seeing how much discipline you are needing to remember always to run the right test first. It's not easy. It requires from your discipline. It requires a lot of forethought. and you can make as many issues as with actual test. TDD is easy when you get handle of it. It's not easy to learn. It's skill that requires a lot of practice. It brings a lot of values in the long run. As you could see here, we're bringing some issues to forefront, but it is it is hard to do sometimes. As you can see, in case when we wanted to do the last one case, I kind of screwed up. I screwed up big time on the whole for loop, and I didn't know how to properly exit it. Probably, if I wasn't being here with you looking, I would be spending some time of Googling, and I will do it after this presentation. Because I'm not satisfied with the solution I done here. I think there is better option to do. And on my part, this is all. If you have any questions, I will wait another 2-3 minutes and I will be answering them. Yeah, so it looks like there are any question. Thank you. I am Maciej Wrodek. It was great to be able to present for you. You can find me on LinkedIn as Maciej Wrodek. I am on the Twitter as IT Morning. I have the Facebook profile IT Morning. And you have a link to my GitHub repositories, so you know where to find me. Thanks for your time and have a great day.